Hello, everybody. Welcome to iScan webinars. And today will be the last webinar for solid H part. We still gonna have some webinar on other topics, but for iScan, this one is the last one. And today we will try to cover two of the interesting functions that solid H provide. One is simulation, and the other is generative design. Basically, what they did is they do like a study and tell you how the part will perform under certain circumstance for simulation. And for generative design, they will, based on the simulation readout, try to give you some automatic, let's say, geometry optimization so that the part you design can be weightless, which I think is a good thing. Okay, it will be really helpful if you want to do 3D printing with your design. It can help you both save material and increase the productivities. Okay, so let's take a look. First, let us look at the simulation functions. All right, for Shining 3D edition, which is available from us, the simulation function is actually limited, so only certain functions are available. I will show you which kind of simulation you can do. All right, but theoretically, not theoretically, actually, you can also buy the add-on for simulation from us. It's called Advanced Simulation, so that allow you to have access to all kinds of different simulations. Generally speaking, there are two main things you can do. You can do force or dynamic load kind of simulations, and also you can combine thermal dynamic simulations onto it, or static, based on your choice. So this simulation function cover both heat and cover both thermal and mechanical studies. So you can do both, and you can do both of them at the same time onto one part. All right. And I'll show you later. I will also show you a simple sample of how this simulation can be done. There are a lot of different lessons you can find online from Siemens that tell you, like, for example, how to apply thermal loads, how you can do more complicated simulations. All right, you can learn by yourself, and it's all available. Actually, you can just here learn and search for it at their SolidEdge site, learning site. Okay. All right. Now I already switched to Shining 3D version. You can check here about SolidEdge. Let's see, SolidEdge Shining 3D. All right. So with our version, what's available in simulation is here. So if you start a new study, only linear, static, and normals are available. For later, we only gonna use these available functions. But let me show you what's the difference. So for basic version, you can only apply force and pressure. So you cannot do torque, displacement, or bearing. And also for constraint, you can only do fixed. In our example, I will do cylindrical because it was fixed on a shaft. But for your case, if you want to practice, you can use fixed to do the same thing. So just fix these two surfaces later in the example that I'm going to show. All right. Let's look at example. We will use the parts that we made from the part design sections, and we're going to do a simple stress test and see if this parts can withstand certain load. Okay, so let's do it. First thing we're going to do, we're going to start a new study here. Click on new study, all right, and click on OK. And make sure the material is aluminum 3004, all right. And you can take a look at the site window, click on the simulation, all right. Let's pin it. So basically, you can find, if you cannot find this window, here's a place you can bring it out in View tab, and here we have panels. Make sure you check simulation here. All right. Okay. So you can find out that here we have the static study 1, and we have a small ball indicating the current status. You will find out only a quarter of it is green, which means only the model that's been gonna be simulated. The geometry is down, and we still have other things to decide. The first thing is the load. So here we're gonna define the load onto it. It's gonna be the force, and will be apply on these two bolt holes. Here, and we will set the force with the with our magic wheel. All right, it will be this direction, and the load will be 150 Newton. Okay. Don't forget the other side of the hole. Let me deselect this surface. Here we go. So make sure only these 4 bolt holes are selected, and the load is 150 Newton. Okay. Then the next, after you set up the load, you will see that there's a lot of different load you can apply onto the object. You can do pressure if you want, for like a tank, or if you have the, like here for the demo version, if you have the full package, you will be able to do torque, displacement, or bearing. You can find out the more about these loads here if you move your cursor onto it. Then the next thing, also you can put on body load like gravity or body temperature things. Okay. After you put on the load, the next thing will be put on the fixture. So what we're gonna do is we're gonna fix it at a certain place. For this part, it's actually a cylinder fixture, so we're gonna do cylindro and select these 2 surfaces. Okay, right click confirm. Now you see that here we have 2 pies covered. Now we already have the loads and the constraint. You'll see that we still have 2 more to finish the study. So these 2 are mesh and solving the full object. So let's do mesh first. Click on mesh, and here you can select how fine you want the element to be. Choose level 3 is good enough. Then let's click on mesh and solve. What it does is it's actually using something called finite element analysis. It will try to divide the parts into small element and try to solve the certain load situation with these. And the smaller the element are, the longer the simulation process will take. Okay, so here's our results. You can see the color map for the stress. So different color means different stress here. Then we also have a displacement with the current load. All right, so let's go to Home tab. Here you can change the different contour style based on your personal preference. Then here you see the deformation is actually 10 times larger than the actual size. This helps you to take a look at the deformation more easily. Otherwise, if you just look at the actual deformation, it's actually really small. You can do an animation. You will see that for actual displacement, you cannot even tell the difference. But with 10 times larger, and if you do the animation, you can see how the parts will deform easily. Okay, so it's 10 times larger scale. Okay, so looking at the deformation and stress is one way, but actually for part failure analysis, there's one important thing called factor of safety. This is a thing that we want to check. We want to see if the parts will fail. We want not only the parts will not fail, but it actually have a safety factor that under larger load it still can withstand and function. So let's choose data selection, choose factor of safety, and go color bar. What we're gonna do is we want at the minimum safety factor to be 10, and we want to see the place that's not satisfying the safety factor. So minimum to be 9, maximum to be 10. And you can see that actually the most of the places are are above the safety factor of 10, but only here it's actually lower than the safety factor. So these are the places we're gonna. You can also see where the minimum value is, which is only 7.89. What we want is we want everything to be larger than 10. So what we're gonna do is we can actually go back and change our model. All right, let me close simulation and go back to home and try to change the model. Let's make this round to be larger so that it can actually withstand more loads. Let's make it, let's say 6. Okay. Now go back to simulation. And you will find out there are two marks here. It's actually telling you that since the model is updated, you have to update the mesh and do the solving again. So let's try it again. Hopefully with a larger round, the part should be more stiff. Okay. Let us look at the safety factor. Color bar. Okay, so mainly it's good. The minimum is 9.79, which is kind of okay because it's already a large safety factor of safety. So we're satisfied with the current design, and you can output your readouts as a report, so you can send to your supervisor and have this design approved, or you can also save the animation for the displacement. Okay. So this is how the simulation works. Next, we're gonna look at generative design. All right. So what we're gonna do first is let's open this demo gd.part. We should already send this out before the webinar, so hopefully you already have this on your computer. Just click and open it. All right. You will be able to see this small box with a hole inside. This is a simple part that we're going to do the demo for. Okay. So let's go to Generative Design tab. The main workflow is kind of similar to simulation. Like I said, what Generative Design did is it's actually do a simulation first. Then based on simulation, it will try to optimize, to improve your design geometry. Okay, so first we select the material to be aluminum. It should be already done if you open the part like I did. Then create the generative study, should already be done also. And the next thing we're gonna do from left to right is to settle down the study geometry. So to decide which part of the geometry you want to do study and make change. All right. Sometimes people don't want change for the whole part. For example, in our case, the center hole is holding a shaft, and of course we don't want this hole to be to disappear or change. So we're gonna do a preserve region and select this hole and do an offset of 8 millimeter, so that at this area the hole will not be changed. Okay. And next, same as the simulation, we're gonna put on the loads. For this, we will do a force load on top. Keep the value offset to be default. What we're gonna do is we're gonna flip the direction because we want a pressing force. Okay. So reverse it, right click to confirm. Then same thing. Next is doing the constraints. We're gonna do a fixed for this part because the bottom of the part is fixed on the ground. Okay, so click on fixed. Then let's select the bottom surface here. Leave the offset to be 8 millimeter. Of course, in real cases that when you were doing generative design, you can select the offset to be any certain value that you want. All right. These offsets also means preserved regions. So these areas that's highlighted with different color will not change after the study. All right. This is because, let's say, for example, on the top surface, it's actually withstand the pressing force. So if you remove material from these areas, there will be no enough space for withstanding the force. Same thing here for the bottom fixture. This is where it connects to the ground or other stuffs to fix the parts, so it should not be changed. Okay. So now we have the load case down. You can find out in the Generative Design tab too. Now we have the load case down, and we have the material and preserved region selected. Next thing we do is we're gonna generate a study. Of course, before that, you can put on some manufacturing settings. This is more like for additive manufacturing. So for example, you can do overhand prevention on certain axes. For example, if you want to do FDM printing, you can prevent overhand on the Z-axis because you print from bottom to the top. All right. And also you can do material spreads. This actually give you an idea of how the material will spread after the optimization. You will see the readouts later. I will show you the difference between no effect and struct-like structures. Okay, we'll do no effect first. All right, click on OK, then click on Generate. Here also you can select the study quality as we did for simulation. The higher the quality is, the smaller these elements will be, and of course longer the study time will be. Then the next part is called mass reduction. This actually is the goal for your simulation. You can select either reduce the weight by a certain percentage, which we select to be 50% here, or you can actually use a safety factor so that make sure the whole part can achieve a certain safety factor. Okay. We will choose reduced percentage in our study because we didn't settle down the load case seriously, so it's not a real case. If the safety factor cannot be achieved, you might get an error and will not get any readouts. Okay. So let's just click on Generate. The workflow is same, so the software will try to do an finite element analysis first, then based on the results of analysis, it will try to give you a design. This is a structure that the software is suggested. Okay. And this is 0% mass spread. So all the material is actually more condensed into two column. But if you, let's see, if you choose a struct-like structure here, I'll show you what the difference are. So let's do another generate. Okay. Here it took some time. This will be really helpful if you want to do 3D printing the parts. We did some more study cases with this generative design functions online. Maybe we can find you some links, but there should be a lot of different studies available, cases available already. Okay, so now you see it's more like it give you more branches and the material is more spreading out in the space. Okay, so this is what I'm in. So after the study is done, of course you can look at the stress map. We have a color map of show you where the maximum stress is and where the lowest stress is. All right. Then of course you can also use, if you only have the Shiny 3D version of Solid Edge, which is directly from us, this is all what you can do. So you can take a look at the study, you can do the simulation, take a look at the study, and you can use this as a reference to redesign your parts, of course. But this is only what you can do. If you want to do more with the readouts, you have to buy an add-on called Advanced Generative Design from us, so that you can output the readouts and use it for example, 3D printing. Okay. So with Shining 3D version, you can only take a look at the readouts, but you cannot output it. So if you already have the add-on, here's how you can detach it and print it out. So here in the readouts, right-click on the readouts and click on Detach from Study. So we'll pop up into the construction bodies. Okay. So now what we're gonna do is the design body is what is what the software will output. So what we're gonna do is we're gonna move the original design and change it to a construction body. Then we'll move this solid mesh body to be the design body, like this. And now, if you go to 3D print, you will see that you can output the study readouts as an STL file. Here you can export it for manufacturing purpose. Okay. So this is what generative design can help us. Hope you enjoy our Solid Edge webinar. And if you have questions, you can ask us. Thank you.